Hello there. So today we are continuing on with data general stuff until the end of time. So we are going to be mostly not working on what's here, but still advancing this project. But there's a lot to do with all of this stuff still, but not anything to do with any of this right now. So for those of you who may have missed the end of the last stream, let me give you a quick demonstration of where we're at with this thing. So here we have the micronova computer. All cards are installed and working. This is the 6039 floppy drive working. And then over here on the side, if I click a thing, Chloe, thank you for the 100 bits. So if I turn this key, we're gonna go to reset. Moonwire Ducky, thank you for the tier 1 for 33 months. I appreciate that. Okay. From here on AC Power, what I'm going to do is hit run.
And says if those data lieutenants are the data general, does that mean there is a data lieutenant? Deep thoughts. Happy weekend all. End of line.
Alien Carl, thank you for the tier 3 sub. Holy moly, thank you so much. And for 36 months, which is a amount of fingers worth of months. Thank you so much. So, what we can do next is take a floppy disk, pop it in the drive, close the drive, punch in 33L, and boom. That is the Data General Micronova booting off of a floppy disk. Now, what can we do from here? Nothing. Turns out this disk is kind of useless. And that's what I've been fighting all week. We can't do anything. So this gets complicated from here. So yeah, there's really not a lot we can do. I'm just gonna pop the disk out and close it and shut it all off, cause yeah, we're actually stuck there. So what should happen is you're actually able to just press enter or new line again, and it drops you to the sys program that would then give you a CLI to be able to do things like list to see all the files, and none of those are on there for some reason. I don't know why. So we can't do anything. I have spent all week trying to figure out a way of getting different disks working. I checked some of the files we imaged on there. There's a lot more to go over that I'm alluding to here, but long story short, as far as I can tell, we have no usable software. We have the bootloader that allows it to actually run off of a floppy disk and nothing else. So, yeah.
Magic context subbed as tier 1 and says all the threes, 33. Eyes down for a full house. End of line.
But Jacob, thank you for the tier 1 sub and for 33 months there. I appreciate that. So, yeah. To help you understand what exactly we have going on, I should go over to my workstation now. I don't have everything fully set up, because it's like a whole lot of complicated things in there. Put one of those disks and try the label as a file name. That won't matter. I know exactly what files we need now, and none of those are it. So let me just do two things here. I need to click this, and then I need to click this. Oh, also this, because I finally got that to work. I know why the webcam hasn't worked over here the entire time. This webcam was showing up in the thermal camera stream. Green Source, thank you for the tier 1 sub and for 36 months, which is a number of months. Thank you for that. I really appreciate that. All right, so this is mini calm. We'll get to that in a moment. This is more important though. There we go. All right. One moment. There we go. Okay.
360 subbed as tier 1 and says wow. End of line.
Go Gadget 360, thank you for the tier 1 sub and for 18 months. I appreciate that. Okay, so I opened a issue on the GreaseWeazle software talking about the Data General 2F encoding. Now, it looks like Data General's using some kind of weird encoding scheme for the flux. What do you mean? Do we have to see it all twice? Just say what you actually mean to say. The Data General 2F encoding support here, overlay. What do you mean? Okay. Oh, okay. Thank you. Overlay. There we go. Ugh. All right. I posted about this on the GreaseWeazle stuff. If you want to look at the flux, you can find it on archive.org. It has been uploaded. Actually, 2 samples have been uploaded. And I provided some information about this stuff. But P. Man here made a fork that can actually decode this. And we can create binary images of the data general disks. It is possible. So, this is, it's pretty sweet. Now, we're going to go ahead and attempt to use this here. It's a little complicated, and I need to get the work drive I've been using for this. One moment here, grab and grab. And I'm going to walk you through some stuff, because we're going to go through the whole process. It is a pain in the butt. All right. I'm just going to tell everyone straight up. Literally none of the discs I have are useful. None. I guarantee it. Not a single one. They're all worthless. So we're going to go through the process so I can demonstrate this. Every one of them are worthless, though. You don't have to say maybe try this. No, nothing. All of them are worthless. Okay, so we're going to go to Git. We're going to go over to Pikoman's repo. All right, we're going to pull over GreaseWeazle here. They are one commit ahead, which is exactly what we're looking for. We're going to go ahead and copy this, go here, and then I am going to git clone this. All right, we're going to go to here, and this is where it gets weird. I don't remember exactly how to do this. Give me a second here. Zaphidia, that is the question that I've been working on, and yeah, just one moment here. Okay.
Schneid's up as tier 1 and says completed. End of line.
1 second here. Do I just get to do this? Pip install local project this. And pip is not editable. No. Oh, this. Okay, there we go. Schmide, thank you for the tier 1 sub and for 26 months there. I appreciate that. All right, are the original discs useful? No. What am I missing? Setup tools. Setup tools 5, 6, setup tools. Setup tools, okay. Sudo pip 3, no, pip 3 install, setup tools. It's like SCM setup tools or something. I don't remember exactly what it is. One moment here, let's just figure this out. Is already satisfied? No, drat. How do we do this? I will never make a VNVev. They're stupid.
Says end of line.
Dr. Stuffle, thank you for the tier 1 month, or subbing for 16 months. And Peter, hello and welcome. I didn't do this on my my main system. I don't remember exactly what I did. Now, pip 3 install -e. Requirement, path URL. Obtaining file, GreaseWeazle, but why? Why are you doing that? It's right here. Just now, I think it just killed it all, didn't it? Setup tools. Requires setup tools, SCM. What do you mean dot? Just dot? No, I think it wants the setup tools. I don't remember. This is not the stupid thing where I get to use apt for this.
David Phantom subbed as tier 1 and says end of line 1000. Just kidding. Here is the real end of line.
David, thank you for the 35 months, or no, 36 months of tier 1 sub. I appreciate that. Pip, setup tools.
Ultimate says never fear, I am here. Things are now allowed and expected to go horribly wrong. Please continue. CHER 100. End of line.
Dude, what is wrong with this computer? Ben, thank you for the 100 bits. Okay, this is actually LSB underscore release dash A, okay? I'm on 2204, all right? That's slightly old. About ready to just drag over my laptop. Is there a way around this that isn't VNVEVs or whatever?
Scientist Realson subbed as Prime and says Ubuntu 12 for the win. Also, end of line.
Ubuntu 12 is the best one. You're not incorrect there. But Industrious Ant, thank you for the Prime sub and for 24 months. I appreciate that.
David Phantom says 10,000 CHER 100. End of line.
Pip X. I don't want a VNVEV. I want a clobber system GreaseWeazle and just have that. I do not want a virtual environment. And David, thank you for the 100 bits. Just trying to... Yeah, let me... There's something... Okay. Riddle me this. What is the current version of Firefox? Is it not 135? Right? Like, that is actually the current version of Firefox. Like, Firefox current version. 130. It's close enough. It's close enough. All right. So, yeah, that. Okay. I want you to see this. Okay. There is something cursed about this setup. Okay. Look, it's the return of the lens cloth. Yay, lens cloth. Woo! It's the lens cloth. Everybody's favorite lens cloth. It's lens cloth time. I'm trying to remember how to type. I'm not doing a very good job of it. Okay. I kind of slightly remembered what my username is. And okay, here we go. We're good. All right. So I get this when I try to log into Twitch. Your browser is not currently supported. And I don't know why. This is Firefox. It's 135. That's a very new Firefox. I don't have this issue on any of my other computers. So I don't understand. At all. Had a user agent spoof, never saw it again. That is awful. Twitch is stupid? Yeah. So here's what I'm kind of thinking. Maybe we update the computer. I'd tried to do it, but I got interrupted before. If I spoof the user agent, it'd probably work. Clear the cookies and log in? You know, that's actually a pretty good idea. That might work. How much would it have to download to do the thing? Sudo apt dist upgrade. $400 megs. I know why it's only 400 megs. We're going to go ahead and do this. Oh, dist upgrade is terrible. Yeah, no, highly do not recommend. Super don't recommend. All right, let's just go through here. Let's go through the thing. I'm just going to talk about this while this runs in the background, okay? So,
David Fenton says, let's try my stupidity now that I added the %p as recommended by ramdogcap. David _Phantom__ subscribed at tier 1 and say, end of line. Just kidding, here is the real CHER 100, end of line.
Cool, you found a new command I probably should block. Thank you for the 100 bits, David. So, let's go over the stuff. The floppy drive in the micronova system is the 6039. I thought the 6039 was just a modified interface version of the 6030. The 6030 is the much more common drive that you would get with older Novas. The 6039 is unique in the interface protocol. It's not backwards compatible. And that's a problem because I was going to be reliant on SimH to be able to copy files onto disk images to use with the micronova. My SimH can't even realistically actually properly emulate the 6030, it turns out. At least from my experience, it might be able to. I'm trying version, well, master, current, fork, branch, whatever, compiled, it didn't work. Apparently 3.92 might be better. I tried using Wildhair's version of SimH, which is very heavily modified. That might work a little better. But anyway, long story short is I don't know if I can make disk images using SimH. So I really thought I was going to be able to. That was my ace up my sleeve on this stuff. It may still be possible, but I gotta figure that out some more still. But I'm not sure now. So that's a problem. And that probably means I can't get files onto it, which leaves us with basically one choice. And that's why we're going to actually work on serial stuff in reality today. But I wanted to get this set up because we're going to want to be able to decode DG images either way. I think the only way we're going to get data onto and off of this thing is over serial. I think we're going to have to load software into RAM to run it. Because I don't know if there's a version of RDOS even out there that's compatible with this thing. Sudo do release upgrade. Where's my do release upgrade? Do, oh, it's dash, it's not underscores. Using the dasher, you've not rebooted, fine, reboot. Using the dasher is not the main concern by any stretch of the imagination. I am not currently worried about whether or not the dasher works. Long story short though, no. no, there's not. I think there's something data general in the term info entries, but I remember it being kind of worthless. So I don't know. There's one other problem here that we're going to face, all right? So I want to write a program that can, in machine language for the micronova, so I'm going to have to actually learn machine language, which is going to suck. I want to write a program that uses the device access commands to be able to image disks. Now I thought, again, SimH, use that. I could write the program in that, use that to test it, and then we could get the hard drive working. And then on the very first spin up of the hard drive, we could image it by loading in the software and trying to, you know, just get everything read. That was the goal. The problem is that the hard drive is a 6095, which is weird in the exact same ways that the 6039 is, meaning it is likely command protocol incompatible with the 6045 drives that are in the 4X, meaning I have no way to develop against it. As a matter of fact, there's not even documentation on the 6095. It may as well not exist. I think it's referenced like twice in 2 manuals or something. So it's really not looking good. I'm still figuring stuff out, but it has not been a great week. So yeah, I have spent my whole week researching different avenues, trying different things. So yeah. So right now, I don't fully know what the optimal path forward is. I think what I might try to do is go ahead and still try to write the disk imaging tool, but we'll have to debug it against real hardware because there's no way to emulate the 6039. And then we're going to hope that the hard drive is the same protocol. So on the data general, on the Nova 4X, the tall cabinet that we haven't even touched yet, if that had the 6030 floppy drive, it would be the exact same command structure as the 6045 hard drive. They're identical. They even share a daisy chain cable bus. We can confirm that, find information about that in manuals and stuff. That is rock solid information. I know that. I could try and find a 6030 floppy drive, by the way, but you know how likely that is? I'm going to guess not very likely. What I'm kind of hoping is that the micronova works the same way. It's just the 6039 and the 6095. Because the 6095 hard drive I have on the micronova daisy chains over the same bus with the floppy drive. So it's pretty likely gonna have to download 3 gigs. Dude, why don't I just download the ISO? That would be like smaller, wouldn't it? I don't know, let's find out. So yeah, I don't know. Like I said, we're gonna write the software with the hope that it working with the floppy drive will mean it works with the hard drive. Yeah, we're doing a disk upgrade because apparently a 2-year-old operating system, well, 3-year-old operating system-ish, is too old. Nerds. So yeah. I will say there is one other avenue I'm going to look at. I don't know how it's going to turn out. But there is a different path I'm going to attempt to pursue as well. But that one's a lot more complicated. So yeah, that's where I'm at. So we need to get a serial interface working because I need to be able to interface with the computer to be able to like do anything. So yeah. Oh yeah, also I had it up for a little bit and then didn't have it up here. What model number for the annoying hard drive? Yeah, 6095. You're not going to find anything useful. There are no manuals or anything. I've already searched through it all. There's nothing. I got to be honest, it's also way easier to search through it when you have it all just scraped. The folders that the files are actually really well laid out. Figure just want to double check. Yeah, so 6095, that's what it is. It's about as vague as number you can get. Nah, that's like straight up data general part number. When you go to initialize a disk, it just asks you what the part number is. And that's also one of the reasons why it kind of doesn't matter if we can get the SimH files onto the machine. Because we need a version of RDOS that actually supports micronova. And I don't know if that's out there. So one of the files that should have, in theory, been on the boot floppy is dkinit. And dkinit should be able to not quite format, but like set up. I'm not exactly sure how it works. Maybe it formats the disk. I don't know. But you should be able to, let's just call it format, blank media for use with the machine. When you go to use dkinit, it asks you for that model number. So in SimH, using RDOS for a Nova 4, you punch in 6030 and it recognizes that. Which means it's going to need to support the 6039 or the 6095. And they don't. At least not on that one. If I remember right, you can get it to list out the drives it supports in. None of the ones that it has are what I have. So even if I was able to take one of the known copies of RDOS and move it to this machine, it still wouldn't work with it. The other fun thing is, the version of whatever is on this boot floppy. I'm going to pretend that it's like CPM right now, because that'll help explain this. So the way that CPM works is you have the BIOS on the floppy disk, and when the machine first starts up, it goes to the very first sector of the first track and then just starts raw executing code. And that code is usually set up in such a way as to load part of the operating system into RAM and then start executing file system commands. I'm pretty sure that's similar to how this works. Because the 6039 is different from the 6030 and the 6045, it means that any disk images that are currently out there don't have the right instruction commands for loading the file system stuff into memory. So Altos has similar boot sector. All right, it feels like something that makes sense for mini computers and stuff. I'm pretty sure going all the way back to the IBM 3740 or 3470, it would be basically the same thing. You'd have the microcode for the machine on the floppy, and that's just basically how the mini computers and the S100s, which like S100 systems are almost more mini computers than the micronova is. It's kind of ridiculous, but yeah. So we would have to be able to modify data general file systems in order to add files to them. Now, here is the one possible method that I can see going forward to potentially be able to get files onto the machine, okay? This is the single path that I think exists. Kind of, Majenko, kind of that, but different. We don't take any other boot disk, okay? We take the copy, the digitized copy of my boot disk that works on the Micronova, and then we access that as a 6030 disk within SimH, which will skip the boot sector part and only look at the file system. And then we can add files to that disk using RDOS in SimH, and then we can attempt to write that disk back. Now, we can't do that yet because we can only currently decode the 2F stuff. Kerf is working on this based on Peter's work for decoding. I'm hoping he gets writing added in the first version. I don't want to like look a gift horse in the mouth here, but without being able to write, decoding is kind of not that helpful. So we need to be able to write an image back, and then being able to copy files within RDOS is the only way we're going to make any progress. And for that, we're going to have to hope that the sys, CLI, and other programs are similar enough once you're within RDOS that they will still be compatible with the Micronova. I don't know. I could see the sys command having all of the machine code things for like listing disks and stuff in it, so I don't know. We just may not have an operating system. For giggles, let me go look at Novas Are Forever, because I don't remember if I actually looked if there was any Micronova specific software. Those are all floppy images without touching the hard drive. Correct, but long story short, it turns out the software for the microsystem is very different. Yeah, so, which isn't much help in itself. Yeah, I do think that's one of the two things that exists out there. The other one is just like an initial setup guide for the thing. So, 9-track Micronova. Okay, RTOS. So, but what is RTOS? And why is Micronova not here at all? Let's just try micro. Wow, there's nothing here. I know what RTOS stands for. RDOS compatible. Intriguing. Where'd you even find that? Is that in the emulator page or something? It's not here. Unless he has tapes somewhere else. Software. Okay. There we go. DOS, bad. Oh, that's interesting, though. 3.5. Boot 6.4. Was... So we were able to extract strings. Was Rev 3.5 the same as what was on my disk? I think it was, isn't it? Oh, no. No. Oh, no. So about that serial program loader. What is this PDF that has like a green bar background? This is text. This is not a scan. It's not, this is already straight up text. It's already OCR'd, which is a little concerning. Huh. DZX, so I'll give you the real explanation. 1,700 pages. Technically, I could type that into the machine right now. I think. I'm not 100% sure. Without mistake, first times, yeah. All 1,700 pages. That's not happening. Interesting. You don't need an assembler if it's machine code. I'm pretty sure this is the machine code. It's all octal. Control A, Control C, Control V, and text edit, yeah. Maybe. So I don't have a paper tape reader. That's what these things are, the 9-track files. This is one of the things that is our only hope of being able to read data into the machine and why we have to do serial stuff. Because if we can load this via serial straight into RAM, then we could potentially load the 9 tracks. But I don't have a serial interface. I don't have a serial reader, or I don't have a paper tape punch reader. I don't have a paper tape punch interface card, and nothing for this thing is easy to get. All right, let's look at some other stuff. MPOS, I don't think we want that. Okay, RTOS, RDOS compatible. That's so weird. Okay, so it doesn't matter if I had a paper tape reader. I don't have an interface for it. Like, I own CD drives. They're just as easy to connect to the micronova as a paper tape reader would be. I don't have an interface. No, I can't make one. I am describing the thing that we need. We need serial. That's what we need. So my machine has the console debug ROM, and with that, we can write memory. So what I need to do is 9-track, not paper tape. Maybe it's magnetic tape. I don't know. That's even worse. Because I definitely can't make a mag tape. That's for sure. It's reel to reel. Anyway, that would explain why it's binary data then. Mag tape. Okay, yeah. It's super never happening then. I want it to happen, but it's not. Anyway, we're going to have to load it in over serial. That's what it's going to be. We're going to have to write all of the data into memory. Yeah, so we are actually doing the upgrade in the background now. I'm telling you, Big Linter, it is not a problem that you can just think your way through. It is equally as practical for me to try and connect a CD drive to the micronova as it is anything that these files are made for. I don't want it to just display hello world. At some point I will do something to that effect once I start learning how to write my own software, but yeah. Serial into the monitor looks like the only way forward. Yeah, I'm pretty sure that is it. All right, security information. According to audit by some dude, current implementation of something is vulnerable and vulnerable to multiple types of attack. Oh, GS sucks. Until these are resolved, the thing should not be considered a safe home for sensitive. Okay, I don't know what thing is, but sure, why not? All right. Yes, I have a 6039 floppy drive, Phil. Yep, okay, Phil, you found it. All right. Yeah. Don't ask that. Don't contact them. Just don't. Just don't. Just leave that to me. Yeah, it has to be me. I'm currently, as far as I'm aware, the only person on the planet set up to actually image micronova floppy disks. Yeah, I did not mention that because I don't want people contacting them. I don't even know why Thunderbird's installed. If I had a boot disk, the boot disk is useless. That, long story short. The most useful thing about the boot disk is that it has the bootloader. That's it. Is that the instructions for actually launching into the RDOS, it's not quite command line. I don't boot instruction thing. I don't know. RDOS is weird, man. But there's nothing. It can't do anything. It's very frustrating. In the background, we're upgrading my workstation to, you know, I actually don't know what. Hopefully 2404. And then we're gonna go through some stuff. So I have no idea about a Synaptics Lisp machine. But same thing. I don't know. Willie, I'll just re-explain it one more time since you weren't here. And just to summarize the situation that we are in, this is the boot disk for the micronova. It contains two things. It's actually almost completely empty for some weird reason, okay? There are two things on here. One, the raw boot sector that allows the machine to load in the initial software that allows it to access the file system on the disk for RDOS. The second thing it contains is the boot command, which I don't really know what does, but I think it just tries to load another machine, another drive or something. But it can't do anything on its own. That's it. There is the boot sector and the one useless command. There should be more files that are more commands, like the actual command line interface is sys.cv. Doesn't exist on here. There should be dkinit for formatting disks. doesn't exist on here. This boot disk only has the boot sector. That's it. As far as something that's actually useful. So we can get to the point where we could run an RDOS program, but we don't have any RDOS programs. So, yeah. And currently, there is no way possible on the planet to get an RDOS file onto a disk without having another machine that has the files already. Yeah, no problem. That's the, yeah. Yeah, Frampton, yes. It is very likely that all of the other files are on the hard disk. Bringing up the hard drive is no small feat. And I'm kind of trying to find a path forward that doesn't require the hard drive. And I'm trying to think about the best way to describe this. I would like it to be a fully floppy system. I don't want to use the hard drive. It may come to the point where I have to extract the data from the hard drive, but that's going to be really complicated. Yeah, imagine it's a DOS622 disk that just has msdos.sys on it. Not even command.com, just msdos.sys. Hard drive has crashed heads. It only has crashed heads on the removable platter. So we could actually use it as is with the integrated platter. And assuming they weren't idiots and the operating system files are on the fixed platter, they're probably okay. What is Simulogix and why does it have backups of Wildhair stuff? That's pretty handy doc there, though. I'm just going to put that in Discord so I can get back to it later. Control Fing through some of the files now. Looks like some version of micronova DOS use DOS in it instead of DK in it. That is good to know, but it does not matter. Here, we can just do this. So I already have a decoded version of the disk image on here. So I'm just going to download this. boot.img. Here we go. So this is the decoded file here. So what we're going to do, we're going to open a new thing here. This is the boot floppy, okay? This is this right here that we're about to look at. Strings, hold on. Strings, boot.img less. The way this works is there are file names at the top for the table of contents, and then the actual data for the programs after. This is the start of the program that is boot.sv, and this is the table of contents. Boot.sv is the only file on here. There's nothing else. This is why this sucks. Do I have the decoded image for the other thing? Because I can demonstrate this a little better with this one. I do. Okay. So the trade shows folder or file, I've done this with as well. Strings, trade, less. This is kind of interesting. So here we have the file names, ADV names and ADV SNDX. Those are the only two files on the disk, and then all of the file data. Just to give you an idea of how this works. So I've been going through some of the disk images and doing this, trying to look at what files they may or may not contain. And even when the names are at the top, the files aren't necessarily there because basic showed up as a file name in the backup HP1 disk, but basic is not on there. I checked this morning. So, yeah, but we don't have DOS in it. We have nothing. The other thing is that I was able to boot SimH and then load the boot.img file in a second drive to be able to do a directory listing of it. Boot.sv is the only file in there. So confirmed from the table of contents, it is the only file. There is a minor possibility that some of the other disks will contain something, but I am very, very, very confident they are all going to be nothing but customer data. And the customer data is super boring, by the way. It's so bland that I would probably be fine publicly releasing it because it's not too much more than a phone book. But there's no reason to release it. Boot.sv is broken on Wiles Heritage tapes. Interesting. I don't know how it's helpful, though, because boot.sv seems pretty useless. Yeah, that's where we're at. It's not great news. So, yeah. Serial loader then? Yeah, that's what it's going to have to be. So, for the record, let me just go ahead and grab one of these. DOS 9-track, okay? So we have this. We can open it with, do I actually have imhex installed? No, that would have been smart. Do I have blast installed? Nope. I probably have XDD or XXD. What on earth funny color nonsense is this? We'll just ignore that for now. XXD, what was it? 0 something? Yeah, that. Okay. Less. All right. So if we look through the 9-track file, we do see text in here. And as we scroll through, bingo, real text right there. So it's fairly likely that we can just load that in the background or into RAM straight up. I don't know where to put it, but it should be possible. I assume the way that the MagTape reader works is it just starts cramming everything into RAM sequentially, but I don't know where. So maybe we can find a manual for the MagTape interface and then see how it works. Because, yeah, this looks fairly likely to just, be the binary data. So there might be some header or something at the beginning, but yeah. captured sequentially numbered files, no file names or anything? That would be a problem, Ben. I don't like the sound of that. It sounds very likely, though. Uh-oh. That would mean it won't work. $60.12. Yeah, keep the local one. Don't automatically update. Although it can because of the way it works right now. But 6021. That's what I want to look up. Archives, documentation, hardware, tape drives. 6020. It's probably close enough. 6125. Okay, we'll look at 6020. Dual mode, tape drive terminator. Okay, read write interface. That might be what we want. Nope, that's schematics. Tape transport manual. Let's look at this. The worst possible thing is that it can rewind. Oh, it can rewind. I've never seen it with the door open. It can rewind. Okay, so we can't load 9-track files straight into RAM. Oh my gosh. Oh, this sucks. It's not quite worst case scenario because we do have the hard drive that probably has the operating system. If we didn't have the hard drive, it is worst case. The problem with the hard drive, though, is that I want to image it. Yeah, Phil, that's the problem. I want to directly image the drive. Default do whatever. How are the platters in the drive? I mean, I assume they put them in and then they screwed them in. I don't know. We can't see them. Well, Ben, this image is all I need. So the channels with the tape looped over are vacuum channels. The holes there are for air to pull air through. The only reason you have vacuum channels is because it moves the tape back and forth. So it is random access tape, which means that the 9-track file is going to load in a control program for that. Care about the controller? Want to see a bootstrap ROM? I mean, it doesn't matter because we can't use the 9-track files. That's what I'm saying. Because as soon as the bootloader for the 9-track file starts up, it's going to try to random access the tape. I don't have tapes, Diego, so I'm not. Okay. Our only path forward right now is trying to image the hard drive. That's it. That's all we got. Ben, you weren't here at the start, I think, so you didn't hear me talk about this part. Figure out how the boot proceeds. Might just load RDOS starter system, dump that into RAM. Maybe. But we get RDOS starter system now off of the floppy. It's just worthless because we have to type in the file name. Anyway, so Ben, we've kind of been over this in Discord. Removing packages can take several hours. I don't think it will. Sure, go for it. The 6030 and the 6045, the drives that are not in the micronova. The 6045 is in the a bit after the boot SV prompt you're getting. So you're talking about sys.sv then, essentially. Anyway, let me go over this again. The 6030 and the 6045 are the, let's call them parallel interface, hard drive and floppy drives. They use the same command protocols for accessing the files for, or let's call it sectors, the sectors off of the drives. So the raw programming interface is identical between them. It's just how many cylinders and how many sectors they have. So if you have a 6030, you could also interface with a 6045. They're completely compatible. I only have the 6045 in the other machine, but we're not working on that one right now, so just put that out of your head. Essentially, we don't have either of those. What I do have is the 6039 and the 6095. They are the micronova versions of those drives. Now we have zero documentation for the 6095 for some reason that I don't fully understand. I wish I had any clue of how it worked, but we don't. But we may be able to assume that the 6095 works with the 6039 in the same way that the 6045 works with the 6030. So it may be command compatible. So I'm thinking our next step is to write a machine code program to image a 6039 disk on the micronova by running code in the machine monitor, well, from the machine monitor. We use the console debug ROM to load in our code into RAM and then execute that code, which will run the direct commands on the specified disk interface to go through each sector sequentially and dump those out over serial to a modern computer receiving data. About 95%, 6095 same controls as 6045 with the micronova bus, not the Nova IO bus. We might be able to hit that with same commands. Yeah, okay. You are at basically the same point I am then. Because that's what I'm thinking as well. Bit savers is 6095 manuals. Really? That is not it. That's the setup guide that just tells you how to put it in the box. Disk controller. That's the schematic. This is schematic, and this will be schematic. So no, we don't have, there's no manual. So when I'm talking manual, let me show you, let me give you an example here. So if we go documentation, hardware, Nova and Eclipse CPUs, we go down to micronova. We want the technical reference here. Actually, let's just do this. Oh wait, I'm not signed out of GitHub? What? That's weird. So if we go to the technical reference, and then we scroll down some amount, say about here. I forget exactly where it is that we want. Async board, this is probably close. I nearly nailed it. Okay, this describes how to interface with the 6039. So this is the manual for the micronova, but it actually talks about how to interface with the 6039 floppy drive. Specifically, it gives us the commands here for how to read from the drive. We need this. We need the command data. If we had, I mean, we could theoretically try to dump the ROM from the drive, but we would need so much disassembly knowledge and reverse engineering on that to understand what it does. It would not be practical. So the 6097 is the double-sided version of the 6039. So that's a floppy drive. The commands are probably the same. Is there someone who might have that manual? I mean, theoretically, they aren't all vaporware, yeah. Let me put it this way. Everyone I know who does micronova stuff is in a Discord server, and they don't have it. Micronova more powerful than the Apple II. I don't know that they're really directly comparable. I'm going to say no, though. Pretty sure not. Has a 6045, yeah. But the 6045 and the 6030 have the exact same command set. The 6030 and the 6039 do not share the same command set. So let's say Nova Classic, okay, the floppy and hard drive are the same, but then Nova Classic and Micronova are not the same. So I think we can assume that Micronova hard drive is not going to be the same as Nova Classic, but it's probably the same as the floppy drive. But we don't know. How's my week been? Awful. Other than the rain, that was great. Sharing command sets, Nova Forever Guy says 6095, just Micronova in same post. So, but that's what I'm saying, Ben. It is the Micronova version of it, but it has a different interface. We're kind of going over it, Jason. Right now. Apart from you asking, what's the 6095? That's the only hit for it. That's amazing. Yeah. The interface is entirely abstract. That's kind of what I mean, though. If you go back and let's take a step back here, Ben. I kind of didn't really show it really well. I rewatched my my first video on the data generals this week, and when I had the camera behind the machines, I really wish I had my phone. I have now when I was doing that, but on the back side of the 6095, there is an interface board that is separate from the hard drive. And it is unique to the Micronova. It is not the same board that's on the 6095. I think what is in front of that interface board is identical. Although the cable that goes from the interface board to the drive may not be. I need to double check that. But I think the 6095, yeah, it's just a controller with a different interface bus. You don't need to care about the bus interface. You need to care about the commands. That's what I'm saying, Ben. There are two possibilities. There's what you're saying, where it uses the exact same commands as the 6045, which would then mean that the Micronova has to support two disk command structure format things, or it could be like it is on Nova Classic, where the floppy drives and the hard drives share the same command structure. And I'm leaning towards the Micronova having the same commands for the floppies and hard drives, and they're just different. But there's really no way for us to know because we don't have the 6095 manual. Yeah, the 6039 command set does not look as good. I was comparing the two at some point this week, trying to determine like how feasible it would be. Also, now that I think about it, isn't the 6097 dual disk system including controller? Yeah. It's the double-sided version of the 6030. So who is saying, do we... What commands does the 6097 use? I assume it's the same. It can't use the same controller. Interesting. Has a single bit to specify which unit you're addressing, and no head field. It's single side. Okay, then there's something else. There's a different drive then. It's not the Echo. Oh, wait, we're upgraded now. Hold on, wait a minute. Dude, why funky colors? What's with this? This is probably LSB underscore release dash A. What are we on? 2404, yeah. Why funny colors? Weird. Anyway, pip install dash E dot. Oh my gosh, it still didn't actually fix it. Are you kidding me? Python 3 XYZ. Oh, yay, this fun. Sudo apt install this. I might be able to log into Twitch now. What do you mean can't find package? This maybe? Sure, yeah, give me all 75,000 whatever nonsense is. So you're saying, Ben, using the weird parlance that I am, the 6095 or 6097 plugs into the same... $6097 plugs into the same interface that the 6030 and 6045 use. Dude. Why? Oh, it's not writable. Sudo. It's not a placeholder name. It said it literally wants XYZ. Right? Or no? Pip install dash E. Oh, wait. I need break system packages on this. Dash E dot. Boom. Get wrecked. There we go. All right. We're all cool now. Everything's fine. Don't worry about it. It's all good. Okay. So, an hour and a half later, we can do this. GW convert this slash track 000 dash dash format. I don't remember what it's called. Scripts, data, the generalist data, FMSS, okay. Format, data, general, nope. Data, general, dot, FM, dot, SS, test.img, and badoom doom, there we go, okay. So we can now decode data general files right here, and it works. Boom, that's decoded. Sudo apt install imhex. Does this work? I'm gonna guess not. That figures. Let's just go grab it. Not Wikipedia. GitHub, there we go. I couldn't tell that was it because I used emojis in the title. Okay, is there a deb file? Why are there RPMs but not debs? Boo! Oh, there are debs. Screw you, Appalachian. Thank you, Final Kneve. What do you mean, bong? There's no notifications anywhere. Oh, it's probably on the stream PC. Probably complaining it wants to update. All right. Do this. And then we do everyone's favorite dpackage -I imhex. Why are you not? Oh, -I. All right, there we go. Or not. Sure, just install games for Windows Live. I don't care. Sudo apt install. Fine, we'll do it the boring way. Today's really not going like I thought it would. Okay, back to here and here and here. Trade no HP test.img. This is the one that we just did. Open with imhex. A. All right. I don't need this. Yeah. Okay. No. Wait, that was supposed to be okay, sure. All right, here we go. Yay, it's a file. So this is the HP file. Okay, we got it's not bootable, is it? Let's go see if it's bootable. I forgot it might be bootable. It won't do anything, but it would be nice to have a second bootable disk. Okay. Drive. Terminal. Capture. Reset. Run. Dude, it's so nice this thing just works now. Oh my gosh. Power, or floppy drive, HP backup, 33L. Whoa, that's different. So this has the microcode for booting or whatever, but I guess it just doesn't have the file. Huh. I don't think we've ever seen it act like that. I'm just gonna grab a random disk. This is advertising list, just for giggles. See what it does here. This is one we've already imaged.
Your word for it. CHEER 100. End of line.
There you go. Hey, look, it's the things in the stuff. Okay, so when the disk does not have valid data, it just hangs. So yeah, HP backup 1 whatever actually has the bootloader. Weird. Yeah, I don't remember anything else having anything interesting like that. It's just this one disc, for some reason, is almost interesting. All right. And boop, but actually boop. Okay. Thank you for the 100 bits, Ben, by the way. All right. Serial terminal, my nemesis. All right. Yeah, anyway, one of the really irritating things is that if we go farther into this disk, so this is the like real file for all the data, but down here it lists basic. Now, I think basic.dr is a directory resource, maybe? It's some kind of cached table of contents. So it's possible that it means that this disk was used with BASIC at some point. Not that it ever had BASIC on it. That's my suspicion, at least. Because when I've opened a file, excuse me, an RDOS in SimH, which we can work on compiling that now, it created a file like that. Can you let me see that directory entry again? That's a symbolic link to BASIC on the fixed platter of the hard disk. Dude, it can do symlinks? That's kind of cool. All right, hold on, mhex. Yeah, I remember. Never mind. I'm starting the... No, you're seeing it again. I don't care. Scroll, 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 scroll. Whoop, there. Ooh, wait, what's that? I don't remember that. Scroll, scroll. Wait, this isn't even it. This is test. I don't remember what this is. Yeah, close. Don't care. I didn't change anything. Why is this saying did I change anything? Wait, that was it. You know what? That's fine. Fine to get your screenshot ready. That's the sysdr. Sysdr. I don't need the pattern editor to be so big. Okay, hold on. Slow scroll. Or you know what? Control F, string, basic. Just be smart. There you go. That's a symlink. Disk, hard drive, unit 0. What? You sure about that? Is disk hard something specific to symlinks? I don't think so. Unless the operating system here works differently. Are you getting that from a DOS manual or an RDOS manual? Because when I have used SimH, which let's go ahead and get that downloaded, It is DP0 for the hard disk or DP1 for the floppy disk. You can symlink to another device. Yeah, but I don't think DH is correct. SimH is a complicated one. DH is your hard drive. I will prove that it isn't in a moment. All right, we got to run a weird Travis command here. Thankfully, someone has a really nice description of how to do this. So we're just going to do this. Yoink. Boop. Control F for 6095. Okay. 695. Okay. Storage capacity 10. Yeah, that makes sense because it's double-sided. Go again. DH. Now that's weird. What else is in here? So this is unique. Wait a minute. Enjoy a different lens cloth. Oh, wait, I probably didn't even... Wait, did I even set the correct webcam? I don't think I did. No, it's just black. Why is it black? Oh, it's black because that is the correct webcam. Okay, well, let me just nudge that up slightly. Let me just nudge that down one. Let me just make that slightly taller and then slightly wider. And then nudge. There we go. One moment, I can't see chat right now. La da 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 da. Okay. Yeah, maybe the commands are different between DOS and RDOS, because you guys were looking at actual DOS, not RDOS. I need a specific recent picture or to stand up and walk over to the computer, which, I mean, who wants to do that? So I want to look at the picture. Nope, the picture sucks. Okay, I'm going to go take a new picture. I will be back in a second. My phone's over there. Hello. All right. It's time to get some answers. And clean a lens. That's a big board. Oh my gosh. Okay, this is Okay. Huh.
Chlorocoon says CHEER 100 time to get some answers. I bet they come with new questions. End of line.
Oh, they absolutely do. Ah, there's one answer. Dude, Data General, what's wrong with you guys? Ugh. Oh yeah, let's put silkscreen text over copper text so you can't read either one of them. Brilliant. All right. Does this got words on it? It does. We've been raided. Uh-oh. T2SDE and Raiders, hello and welcome. We're kind of taking stock of where we're at with this project right now. The hardware all works. Well, we haven't tested the big complicated hard drive, but that's like a whole other problem. But we don't have any software, except for possibly on the hard drive. But working on that is we gotta have all our T's crossed and our I's dotted. Anyway, some very, very helpful information here, and something I would not have considered that is most definitely true. I want to see if I can see something on the back of this really quick. Okay, that's how that works. Kind of. Interesting. I haven't looked in the 4X cabinet, well, since I moved into the office. All right, let me get these pictures uploaded. We'll take a look at them. Consonants of the hard drive are lost. No, they're not. No, they are not. The crashed head that Usagi mentioned is on the removable platters, not the fixed platters. We don't know what the condition of the heads are in the fixed platters. Probably better in the removables, but we don't know. All right. Let's boot it then. Yeah, sure, okay. Let me bring this up. Okay. This is what's on the back of the 6095 hard drive. I did not realize this was here. This is a wide ribbon cable that basically adapts the 6045. You know, I'm just going to go really quick double check that the back of that hard drive says 6045 on it. I'm pretty sure it does. Never mind, I can't really tell because this board goes all the way up against it. I'm just going to assume that it is. I could remove it, but I could also just not. So here's the interesting thing. This M something disk controller. This is the actual disk controller on the back of the drive, which makes sense because that's the test mobile. This is the interface. This goes to the back plane of the computer, just straight up. Huh. I guess there's no reason that it would have to share the command structure of the floppy drive. It could be the same as the 6045. But this board is unique to the micronova. This is effectively the same kind of thing as putting a card in the cage. It's just they put it on the back of the drive instead. But this connects to the data pins on the card or the back plane. So I think you could conceivably say this card is the 6095, but then the drive is the 6045. It's not a, well, in a very irritating way, yes, Philip, you are correct. Early IDE. Yeah, let me go look at the back of the micro or the 4X drive. It's the exact same ribbon cable situation. Okay, it is probably 6045 commands. That's really good. It is really, really good that it's 6045 commands. If I run one more, if I run a CMake here, you'll see why that's really good. So, Usagi, I don't know how much you've been here for. So, I've been just rolled in. Okay, let me, for you and everyone else, let me give a brief summary of where we're at. Okay, this is going to be the condensed version. It turns out the 6039 floppy drives that I have are unique. They have a different command set for accessing the drives, which means that I cannot image a floppy disk and boot it in SimH. It's impossible because the bootloader code on this that accesses the drive is different. So I can never fully emulate the micronova. Additionally, the command set for the 6095 isn't known because there are no manuals for the 6095. So there's a problem with that. Additionally, because the commands interface for the 6039 floppy drive is different from the much more common 6030, there aren't any archived versions of RDOS that are compatible with the micronova. So there is no software out there for it. None of the disks that I have, including the boot disk, actually have any real utilities for using the machine on them. So I'm kind of hosed. Imaging the hard drive that's in there and then trying to boot it and access the files is my only option. Now I say imaging because what I want to do is look at the command stuff. I had it open somewhere here. I want to look at I want to use machine language commands to read sector data off of the hard drive and then spit it out over serial, capture that on a modern computer on the very first spin up of the hard drive. So I wanted to use SimH to write a disk reading program so that I can test that process in an emulator before I go and do it on the real machine, because it'd be cool to not like accidentally wipe it because my program is bad. So I was really hoping to do that, but because mine is a 6095, the hard drive in there was crashed though, wasn't it? No, those were the heads for the removable platter, weren't they? Pretty sure it was only the removable platter. I know you sent me the images, but I think we couldn't see the bottom heads because we got to the point where we couldn't go any farther down in the drive without removing the plate that has the sector ring on it. And you didn't want to remove that because then it would be misaligned. And I don't think we would have cared about that if there was a head crash. So I think the only example I can get for the files for this machine are on the hard disk platter. And I want to make sure that when I spin it up, I can image it. So I want to try and figure out how to access the hard drive, but it's yeah, it's not fun because apparently everything from the micronova is unique. So Ubadistas, I've been saying that for basically 5 years and people have harassed me relentlessly about it. So we're doing it. Remove the top. Fixed looked all right, but the removal is very crashed. I need to scrub through the live stream again, double check. But if we're lucky, the fix might be okay. Yeah, I should be editing that half of it into a video this upcoming week. So I'll be going over that part. And I'll probably include that in there because, I mean, that's a significant part of the story of this machine. So. Works, sure. So yeah, I don't know, man. It's complicated for the micronova, it turns out. I thought the micronova was going to be the easy one. And I'm also really surprised how incompatible it is with the rest of the Data General stuff. We may be able to run the Nova command now. Oh yeah, fun fact. Did you know there's an LGB21 emulator in SimH? Seems like it might be kind of new, but it is technically there. Pulled sector data off the Centurion the first time we got the Hawk successfully spun up, but we reverse engineered enough assembly to write a bare metal program to do that. Yeah. See, our problem is this. So this is the interface board for the 6095. We might be able to find a ROM or something on here. It might be that thing, I don't know. And then use that to try and reverse engineer the command structure. But what we're thinking is, yeah, I'm going to have a guide for SimH if you want a like sensible person's way of actually utilizing it. I've been working on figuring out how to use it and actually writing up information on that on my wiki. The 6095 I'm thinking is actually this board, which is the disk controller here that's like grafted onto the back of the hard drive. It might share the same commands as the 6095, which is a lot more common. So, all right, if we go into bin, is Nova compiled? It is. So if I do this, Nova, perfect, okay. So if I do help DKP, all right, we can see here that it emulates the 6030, whether or not that works. We have that, but we can also emulate the 6045 more importantly here, which means that I could potentially write a program in machine code for the Nova and then test it against this, because this does work. So we could try that. Basically, I would have to test it while booting from that kind of drive, which is a little complicated. But with this, we could image the hard drive in the micronova and then access the files in SimH. So we would actually be able to work with the data if we imaged it. It wouldn't just be a raw binary dump. We would be able to do something with it. It might be possible the same day, as soon as we like dump the files from the hard drive, to actually not boot it in SimH, because SimH doesn't do micronova. But yeah. On that, can you get the same memory monitor in SimH? No, because that's unique to the micronova, it turns out. Apparently the Nova 4X, but I don't know. So I'll mention this. Usagi, my first goal here is I'm actually writing up the goals for this. So this is the software that I'm going to be writing. We're probably going to work on this today as soon as we get everything else wrapped up, but I'm working on a program here. I'm going to dump the console ROM from here, and then I'm going to try and run it in SimH. We'll see what happens. I'm going to guess it doesn't work, but I'm going to try it just for giggles. Because if so, that will be super duper helpful too. But I'm going to try and get the ability to basically debug the computer. I think it's actually going to be possible to even write a GDB server that can control the micronova over the console debug, but that's like a stretch goal. So yeah, it's all pain in the butt, man. Like, it's so bad. Yeah. I have really been beating my head against SimH this last week. Let me do this. Data general, SimH, all. And let's see, let me discover this guy. Creator of SimH was fascinating. Read into the state of vintage computing in the 1990s. Ooh, good idea. Nova instructions should be similar. Micronova does handle some things a little differently. It's annoying if we get to go done with the ROM. It should be port its regular Nova and test that for, yes, use that for testing, yeah. So yeah, my very first goal with my serial interface program is to dump the console ROM, since it is addressed in RAM, because that will be super easy, and then I don't have to desolder it. For everything else, like the 6039 and maybe the 6095, I have ordered the dip tips for my solder tweezers, which should allow me to basically just like pick up the chip out of the board. Not have to do the horrifying dual hot air setup that I was doing before. So, what was I going to look at? Oh, Data General SimH, because I need the prep files. This? No, not the Novas are for everything. Simulator documentation is really close to here. SimH user guide, sample software. No, not Data General. I don't remember where it's linked. Software kits, that's it. Okay. So I want RDOS, which for some reason is the first one. We're going to grab this. All right. Open this. I'm just going to take this. Yoink. Said yoink. Okay. How about extract to? I don't care. Just anywhere. Go. Okay. And then it was called RDOS, right? Sure. Okay. Home, get, SimH, bin, stick that there. Boom. Back over to here. Okay, so we're going to attach to DKP0, RDOS, whatever thing. Boom. We can then show DKP0. It will have show DKP0, except we have to have a space in there. It recognized it as a Diablo 31 drive. That's fine, because that's just the size of the image. It uses that. Now we're going to boot DKP0. We get the file name thing. This is exactly what we see on the Micronova, by the way. The only difference is that this is lowercase. We should just be able to hit enter. It loads up RDOS. We go month, year, day, why not? Oh, I screwed that up, and now we're boned. Reset, boom, boot, DKP0 file name, enter, C, don't worry about that, it's weird. 88, here we go. Oh, I did not set up the terminal. So this is a problem. The dasher is not ASCII. I don't know how to handle this yet. This is what our issue is. So if we close this, reset, okay, I have to set TTI 0 to D200. No, set, oh, I seg faulted it. That happens a lot. We're ready to start working on the drive. Let me know. I can video call or something, walk you through a bunch of the basics. Actually going to go through the same motions as CDC Phoenix right now. It's currently out there purging error through the system. Interesting. So does your CDC Phoenix have the super long PCB? Because if anything, I think that's what my drive is based off of. It's either that or the Diablo 44. It's probably the Diablo 44 though. Anyway, console debug ROM contents are available as PDFs on Novazar forever. Look at CSL debug file list, but reading the ROMs might be easier to get a nice file. We're still going to do it just as a test, no matter what. So yeah, don't worry. Anyway, we have to do, okay, attach, DKP0, RDOS, okay, set TTI0 dasher, then we can boot DKP0 file name, no, continue, year, day, month, I know I got that wrong, and now because it's set to the dasher, the new line works. Hour, minute, second, boom, we're now in to RDOS so we can list, okay? So we're now running RDOS in SimH here, that's what's going on right now. If I were to do this, I'm going to go to here, archiving, bulk image, and I grab the test image that is the HP backup disk. We could theoretically Control E to stop this, attach test. It seg faults because it's the best. What do you mean the dasher isn't ASCII? See ASCII in the disk images? Carriage return or new line, one of the two is not whatever normal ASCII enter is. I don't know why, but it doesn't work. I'll show you more in a moment. Phoenix has a separate card cage in the back of the big hard drives, or big hard drives, mechanical size, moderately similar. Okay, yeah. I kind of have the basic premise down, but yeah, we'll definitely touch base a lot more before I try and crack it open. That's for sure. That's expected. Weird junk. Yep. And Vuki VT and Raiders, hello and welcome. We're currently emulating a machine that's kind of sitting right there. So that is a Data General micronova. We're using SimH to emulate what's probably a Nova 3 or Nova 4. A Nova 3 is the closest that you can get in SimH. Because we're trying to work with disk images and I'm trying to demonstrate some stuff. But I guess I can go ahead and skip a bit ahead here for what I want to do. Because we've been dragging this out forever today because things aren't working well. So here is standard serial shenanigans. We have an actual FTDI USB serial interface. It's going into a USB LED tester. Then we have a female to female adapter. Then we have a DE9 to DB25 adapter. Then we have a null modem adapter. Yep, that's serial for you. Now what I'm going to do is I'm going to walk on over to the actual computer over here. I'm going to hit a button so we can swap cameras. And I'm going to disconnect the serial cable that is currently going to the dasher terminal right there. And, oh, this is always a pain in the butt to remove. There we go. There we go. So that is the serial cable going to the terminal. I'm just going to go ahead and drop that right on there. Just, you know, smack it up. And then I'm going to wonder where I put the other cable. It's under the... Nope, that's the one I just took off. Where did I put the other cable? There it is. Okay. This one has a DB25 connector on it. This machine came with 2 serial cards. This was connected to the other one, but we can just swap that out, and then we can connect our USB serial adapter to this card. Boop, like so, and we're now technically connected over USB to this machine. I'm going to go back over to the computer here. I'm going to bump my mic pack. I wonder if I'm still audible. Looks like it. Okay. I bumped it real good. Real good. Oh, the clip came out. Oh, great. Stabbed through my cloth belt. It's very stuck. All right, well, let's just pretend that didn't happen, and I'll solve that later by taking off my belt. Okay. On here, we're going to run minicom, D, and then dev, TTY, USB, whatever number. All right. Control A, O, we're going to configure it for serial port 9600 8N1, because that's how the actual terminal sitting right there is configured. Exit all of that. Now, I'm going to walk over to the real machine. I'm going to turn it on. And boom, there's the console. Kind of. Here's the problem. I can't type anything to it. I don't know why. So, let me bring some up on Novazar Forever, if I can find it. What was I going to look for? Oh, hold on. Ah, screw it. Let's just do it this way. Button. Look, it's computer. But more importantly than computer right now is computer. So this is the manual for the terminal. That thing. And in that, we have a pinout for a cable that goes to the terminal. The only pin that goes to it for a DB25 connection is data terminal ready. So that we shouldn't need hardware flow control. Long story short, at least I'm pretty sure. There are more pins on the cable than 4 coming out of the machine, but I'm not 100% sure what they are. The reason I say that is because I've tried enabling hardware flow control. It does nothing. It looks the absolute business. Oh, yeah, I did. Yeah, I spent a little bit of time. Also, the back ears are back on because I'm getting ready to re-rack it. We wouldn't see any text if the null adapter wasn't working. Does Minicom know that? Well, I already have flow control F disabled. So there's that. 7 versus 8 data bits. That's an interesting point. I haven't tried that. E, U. Doesn't seem to do it. Parity is none. I know because I can look at the terminal and see that that's what it was set to. Oh, wait, hold on. Let me press the button. There you go. Control A, O, 0-port setup. So there's the current setup. We can enable hardware flow control. It won't fix it. Data bits are wrong. When you see mangled mess, I don't know. Dude, my stupid mic pack. Oh, it's so stuck, man. Jeez. Ah, I got it. Yes. It's stabbed through my belt. There we go. All right, hardware flow control needs to be off. Turning it on only make things worse. Maybe? So exit. Nope, nothing. But yeah, so I don't know how to do this because it's kind of important for what we want to do. Opinions and FTDIs, implementation flow control, they're not good, so don't get me started. Yeah, unfortunately, somebody left all of their, I'm only typing numbers right now, Usagi. Unfortunately, I left all my other serial adapters at home, I believe. So I can't try a different one. I like the 7N one, but the offline means nothing. Don't worry about that. Intercept data from the dasher. That gets to what we were actually going to do today, not just watch me try to tell the tale of what I've worked on all week. We're going to build a serial cable to try and send D-sub DE9 connections to the dasher. Maybe we should just switch gears to that because I would like to intercept it, but there's no way for me to right now. So. I do have the fun serial matrix switcher, yes. That's not really what I wanted to get to today. Didn't you have serial analyzer? I do, but we can't. We have to make a cable before we can intercept it. So, what does the data general device do? It's a computer. It computes. It does all the things a computer can do if we had software. Pinout DB25 may not match DB9 a logical way. Printer use pin 11 DB25. That would be annoying. It's from 1977 way out west. The specs are not going to be relevant to what you're thinking. So here's what we could do. Let's go over where we're at with serial cables. Because maybe we just do this first. All right, so I'm going to turn the machine off. It really does look so good like this, though. Maybe we're beeping out which pins DB25 are connected to what on the Nova. Yeah, so you actually have a really good question that isn't what you're asking. Let me turn off the webcam view here because we're going to be here for a bit. Because the other fun thing about the cables that go into the back of this is that the service notes are full of the service techs having to rebuild the cables because they kept getting mangled. So for all I know, the DB25 adapter cable I'm using doesn't even work. So there's that. What? Hold on, Majenko. One moment. Term console. No! Why? Why would I get that? Screw that. All right, hold on. Let me grab this cable. Let's start with potentially broken wired. Yeah. I need one. I don't even know what it is. It looks weird. I already have this thing. I barely know what it is. Okay. Okay, so we have two cables. This is the one that goes to the dasher, all right? It is terminated in, actually, hold on, a female IDC cable. It's got a lot of data lines in it, so it's probably more than just RX and TX, except it can be a maximum of 6 pins, because if we look at a cable that is actually plugged into the terminal, if I could find it, that's video, that's switches, that's keyboard, there it is. This is the one that goes to the terminal itself, and it's only a 6-pin cable, and at that only 5 are being used. So we only need 5 signals to control the computer. We don't really know what these are, though, because that's kind of what I was showing over here. So this is, again, the manual for the terminal, and it describes the cables for the machine. Now, if I scroll up, you'll see how the PDF loader is awful, and I hate it. Oh, wait, here we go. So this is where this gets really confusing. None of the acronyms they use, they explain or tell me what is. So we have LCD to ALM. The terminal, this thing, is an LCD. I have no idea why they call it that. I cannot figure out what that acronym means or anything. They call it LCD, okay? So LCD, okay, to ALM, and it looks like it's probably this cable. So we could check the pinout of this thing to figure that out. And then look at, see that. But then we have the names for things. TT1 plus, TT0 plus, TT0 RC data, DTR. Wait a minute. No. What? I wonder if we can depin that connector. We can. We can try removing pins and see what it actually needs to work. Is that current loop? No, it's the EIA one. This is for EIA. I mean, maybe this is for current loop, now that I think about it. Let me scroll down. Is this the EIA one? Well, it's got to actually load it at some point here. Yeah, I'm just going to download the file. What page was that? Okay, it's a cable. Firefox just completely crashed. RS422. I am nervous that it's going to be something weird like that, because that looked kind of differentially. Yeah, I know you're having trouble, Firefox, because you're awful. All right, hold on. Let me just bring up the PDF. Instead of depinning, try clipping onto the terminal from regular PC. That way you can go back and forth between the dash terminal program, figure out what the exact pinout is needed. The problem is that what I was showing you for the pin labels is basically all we get. So I was wanting to find, hopefully, that exact cable. There was one that was labeled EIA in here. But I'm now really concerned that it's going to be differential signaling. EIA interface. Okay. See, that's not. So the terminal can do not EIA. That's the one that I was showing you. But maybe the async card? Maybe we need the async card manual. Okay, let's look that up, I guess. Just go into standby. Sleep. There. Let's go look up the async card manual. Maybe that'll tell us something. If we even can, though, because you know how this is. There's like no documentation for anything. Actually, let's go back to SimH for a moment. Let me explain something. Leave Minicom, Nova. So, Nova. The reason SimH is that we have show TTI0. These are the terminals. We have TTI 0 and 1. That showed 0 and 1, but ground the other diff RX pin on the Nova. Why would grounding the RX pin fix... Oh, because... Yeah, okay. Okay. I'm seeing it. So does this have RS 422 wiring? No. Okay, so this is a DB25 like breakout thing. Let me bring the computer back in to this. So this does label this, but it's kind of a pain in the butt. I think we have to open the shell to understand what's going where. Actually, will this even work? Here's the thing, okay? This is the cable that was plugged into the top, into the second card. I think the cards might be configurable for RS-232, not RS-422. I think we should go look at the manual for the card, for the async card, if we can find it, which I think is just in the technical reference for the micronova. Because if this ever had this few pins, then it's RS-232. So yeah, let's go back to that. It might be a jumper away from working on the serial card. So we go here, technical reference. It should be in this. This is the 77 one. Okay, is this? It is. Async. Async board, okay. So there'll be a description of the jumpers at the end of this. Here we go. Okay. EIA RS-232C. Enable the console debug option. Send the modem signals. Stop it. Parity. Bit positions of device code. Why would it be weird? So we can look at how my card is currently configured. Both of them. So the non-console card and the console card. What are different? So 28 is removed on the non-console card. 28 is insert for debug address space. What? Oh no, that checks. Okay. Put this here. 477. Okay, DB25 connector you have had pins 2, 3, and 7, and one more HBRX6 round, and I'm pretty sure it's DTR. That's something else what I'm curious about. Okay, hold on. I can just tell you because it is pin 25, if I remember right. Here. So, this one, okay. So it's 2 and 3 right there. So if we look at my pinout thing here. So 2 and 3 TX-RX, and it's the one right before those. So it is pin, it's pin 14. That is the transmit data for the secondary peripheral, which is what you were talking about, which is a little concerning. But yes, it is the extra one, but we don't know what this goes to. I have no idea what this cable is used with. This does not go to the terminal. It's this that goes to the terminal. So I don't know, but yes, that is the secondary transmit channel for RS-232, the weird one. Pin 14 here, secondary transmitted data, if you want a source that's not me. But that's not the terminal connection. I'm trying to figure out how the terminal connection works. Secondary peripherals. Yeah, but that again, that's not the cable for the terminal. Okay, so let's go back here. 23 is set on both. 26 is set, but that's in the middle of the console stuff, so let's just double check. 26, enable console debug. That makes sense. What else is different? Or 11, 12, 13, 14. Okay, let's check that. 11, 12, 13. That's baud rate. Okay. Just for giggles, let's actually decode the baud rate on both of these. So this one, it's 11, 12, 13. 11, 12, 13. So first 3 in, or last 3 in is 9600. The other one is just 13, which is 300. Okay. Gotcha. Terminal probably implements some form of flow control. So the DB25 connector you have is not meant for turbo, only sending RX6 on ground, which is why you can't type anything but receive. I'm not using that port though. So we have the 2 async cards in there. The DB25 connector was on the top one. Hold on. It doesn't really matter. No, it's 300 because it was, or was it 13? Okay, it was 1200. It doesn't really matter though. So the top card is the one that doesn't have the console ROM. That's where the D-sub connector was plugged in. So this, not that one, this card is one that was plugged into. So it was never involved with the terminal. So the pinout of that one doesn't matter. It's only this one. Okay, so we got 27. Those are all set. Okay, these, whatever these are, 6 and 1 are set on debug, but not the other. Okay, so what are 6 and 1? 1. Ooh! Boot positions, device code. Transmitter receiver. What? Micronova async card doesn't seem to have any jumpers for setting flow control on or off. So if you use DB25 cable with the terminal async card, flow control is getting lost. Okay, I see what you mean now. You're saying the terminal is expecting flow control and it's just not there. Okay. Now I get it. One and 6. Oh, that's the device code. Okay. Huh. Jumper 27. 27 is set on both. It's right here. '21 and 24. Yeah, so RS-232, yeah, 21, 24. So where are those? There will be the jumper map. You can look at that. Maybe. 24 is in a really weird spot. So it'd be 3. Okay, so this is... What on earth? Okay, so 23 or 24 is a dual position optional one. So it's this. They only labeled 23. Both are set to 24. And then 21. Is that another dual position one? Or is it this and they put the text on backwards? I don't know. You know, I think it's that. So there's a 20 and a 21. That should be just past this. Okay, so it's that. And that is set the same on both. So they're both set to RS-232C. So we try and ground RX, even though it should be RS-232C. We try it? I mean, I don't understand now. Does this even say it can do other kinds, or is it just only RS-232? Okay, UART, something or another. $20 milliamp current loop or RS-232C. So it can't do differential. Dude, what on earth is up with that cable for the terminal? Also, why doesn't this give me a pinout of the card edge connector? We just need this pinout right here. Why doesn't it give me that? Well, then we can try that because I can just disconnect all the other bits or control lines, however you want to think about it. So bloop, do. So yeah, RX, TX, ground. That's it there. So we can try that with it. So let me fire up Minicom again. SimH. All right, so we got the data in Minicom, and I'm just going to try typing numbers. Nope. All right, let's do this. We don't know what the pinout of the card edge connector is. The pinout of the terminal is weird. Wait, no, this is what we have to do. Okay, I know what we need to do. You absolutely need to think about flow control. Then why does this cable exist? So here's my thought. Here's the Rosetta Stone for this. Pins 1 and 4 on this one. No, on this are the what you call it, RX and TX, TX RX. So one brown is TX. Not that it matters. Okay, so then that's TX, and not there. Here. So 1 TX, 4 RX, 1 goes to 11 on this. If the null adapter was wrong, then we wouldn't see any text. Okay, I want to try this. So brown, right, brown. Okay, top right should be transmit. Oh my gosh, sucks to pull these out. time to be bad. It sucks that being bad works. TX should be pin 2. Brown to pin 2. Not connected. What even is this cable? Okay. Pin 4. Wait a minute. That would be... No, because that would be for the terminal. So RX, pin 4, on this is yellow. Okay. We go to pin 2 on here. Blue. Confirm. Okay. So blue here to RS232 RX would be here. Dude, TX is not Okay, hold on. A1 is 5 volts. What's pin 1?
Willie Fleet subbed as tier 1 and says, end of line.
Willie Fleet, thank you for the tier 1 sub. And for 26 months. That's this many months. I don't know where you can see. I appreciate it. Hold on here. I need a whiteboard, but someone parked a bunch of test equipment carts in front of their whiteboard. It's okay. We can do this. Portable whiteboard time. All right. Where did I put all my fancy markers? Where did I put all my fancy markers? One moment. Why am I so good at losing every single thing? They should be in this room. They can't not be in this room. Wait, was I really smart and I put them in here? No, I was not. That would be too smart. All right, fine. Garbage markers. I'll find the other ones later, I suppose. Okay. This is that I'm flustered and I'm not thinking. Okay. Terminal 1, 6. This is TX for the terminal. Pin 4 is RX for the terminal. For this thing, pin 2 should be, and then this would be the card, TX, pin 11 would be RX. Okay. To the box. I can see pin 2. Right? Pin 2 is blue. Goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then that would be TX. And then pin 1. No, pin 11 will be the brown one. Wait a minute. Oh my gosh. Brown goes to pin 1. I should flip these. Pin 1 would be RX. Okay. Here is what we have going on. So this is the terminal connector. Pin 11, which would be the brown one, connects to RX on the card. Okay. Pin 2, which would be TX, connects to pin 11 on there. On this one, though, the TX pin, which is blue, get in there, connects to pin 2. No, wait, is that? That connects to pin 3, RX. Wait a minute, do I have this backwards? Wait, what's going on? Is something happening? Oh, 90-second ad, okay. I think RX is not connected on this. I think that's the problem. Hold on. RX, what are you even... Let's just open the shell. Let's just open the shell, man. Why do I not read the service notes? Ugh! I don't even know how to fix that. Can I just push that through and then resolder it, or what? You know what? Let's try, is a pen? No, that's way too big. So frustrating. hold on. I think this might be the answer. Meet Pokerator's cousin, Flatterator. All right. So actually, it's also Brusherator. This would probably be like one of them smart things if you wanted to do some like chip locating anyway. I'm gonna try and push pin 2 just through. Oh wow, it does not want to. Okay. I love how this is literally one of the exact same problems the original owners kept having. Like, exactly. I have an idea. It's not about being able to get the force on there. The pin is just like stuck. Maybe it's keyed or something. I don't know. I'm going to try and get a leg to just solder to that, and then we'll solder to the leg sticking out. So I'm going to see if I can soak enough heat into this for this to work. Use regular solder connector to wire all the pins. I was thinking about it. I don't have that. This is genuinely perfect use case for my little mini vise. Okay, so all we're gonna do is just solder this down in there. Also, let me just hide this. Don't know if this will work. I mean, in theory it could, but I'm relying on the thermal conductance of this cap leg. Whoa, did it just break? It was probably just super malleable because it was hot. Okay, hold on. Won't work. The pins are crimp contacts. I mean, they may have been at one point. They're not going to be now. Oh, come on. We'll make the pliers a lower connection interface thermally. It is a good point about the heat sinking. Okay, all the solder just like drained down into there, and then it still didn't work. What? Where did it all go? Ah! I swear it just broke off a piece of this in there. All right. No, I mean, I can't get the original pin out. It's not a matter of... Here. Do it this way. You all can just see. It won't come out. I can get a very good fit on it, and then it just will not push out. It's like it's splayed in the back in there. If I heat it out, it will not ever hold back in. I think it's latched in. All right. We got I wish I had card edge connectors, man. How does this thing work? It's more than just the... It's not an ISA card. It would be the motherboard for the ISA card. It would have to be destroyed. All right, same plan, different method. I'm basically writing off this connector at this point, so if this doesn't work, oh well. Oh my gosh, how? At this point, it's just going to stick to the plastic. Ah, okay. Suck it, pin. Okay. Huh. You have added enough solder to jam it into the hole. Yeah. Deal. Take it. This is the correct way to heat shrink too, by the way. This is how the professionals do it. There we go. Okay. Look, it's all perfectly better and brand new now. Maybe, probably. Okay. Back over to Minicom. Power. Run. Numbers. What? Wow. crazy. Who would have guessed having all the pins connected would be the trick? We can read a register. We could set a register. We could read a register. Wow, it's nuts. So much wasted time. Dear Diary. So we started on this at about noon. Oh, whoops. DB25 cable was bad again. Temp fix done. Recommend new cable. Closed 3/8/25 at 13:05. Ah. Yes, you know it, digitalization. It's not cursive, but you know, it's just bad. Yeah, so I recreated the original logs as PDFs and printed them out so that I can add them to this. So yeah. So I am doing that. Unfortunately, I didn't notice until today when I was filling out a preventative maintenance thing because I removed the batteries. I screwed up the PDF for this. The periodic maintenances are all number 1 on here instead of 1, 2, 3, 4, 5. It doesn't matter because those don't mean anything anyway. But yeah, so this one is wrong. So what's the disc in the front cover? That is the original boot disc that we've already used. It doesn't do anything useful. So, all right, that's the serial cable change documented. Okay. Put some stuff away here really quick. By the way, check this out. I got instead of just a magazine holder, I got a old office file holder for the manuals and reference material. And that just goes up there now. So when I need some, it's just boom, right there, ready to go. There's the power supply manual. It's going to be pretty handy to have that like that. All right, just do a little bit of cleanup here. Then we'll go work on the software for 5 minutes. Jeez. Oh, wood grain. Yeah, I was very much a stickler. Okay, this is one of those things. I've seen those in Goodwills forever. All right, that's like a ubiquitous thing that you can find there. It's one of those file holders with the wood veneer on the sides. I decided I wanted one, and I was like, I will get exactly that, and it took, I think, 2 Goodwills. I was able to find it. Was that combination of adapters? Yes. It is adapter positive. A less sarcastic answer is that it is DB25 to null modem to a DB25 to DE9 adapter to female to a RS-232 breakout box, which, by the way, is set to 3-wire, so the Minicom connection did work with only RX-TX and ground. And then it just goes to a USB RS-232 adapter. Oh. License plates are mounted to the wall. Yeah, because I said I was gonna. All right. Whew. Design PCB that connects serial card with Pico USB serial adapter you can use as... Oh, well, I mean, we don't have anything to load. So, and we have functional floppy drives. We don't need a loader serial device. We need software, which let's go work on. Yay! All right. So, we're going to mess with this a little bit now that we actually can. The only thing we need on is the micronova. So I'm just going to quickly turn this on again. There we are. And now I'm going to give you webcam view, and we're going to mess with this a little bit. Right. For those of you who are new here, let me explain what it is you're looking at. Or maybe you just tuned it out because this is all like boring nonsense, and I just keep going on and on and on and on. And it's just like, oh, just get to the point already. This is the monitor for the micronova, okay? So what this allows us to do is read and write to memory and start program execution. It can also do a couple of other things related to debugging. They're not super critical right now, but we'll get to those later probably. So what we could do at this moment is investigate, say, memory location 2 by typing a 2 and then a /. We can see that memory address number 2, excuse me, is set to 177777 here. Now, this device is octal, which means that our values are 0 through just 7, not hex. So the numbers that you input into here can only be 0 through 7. If I type an 8, it has no idea what I'm talking about, and it errors out and clears the command line. So the only things we can do here are read and write memory effectively. This cannot list disk contents. It can't run software. I mean, it can, but you have to type in the manual, the machine instruction codes in manually into the RAM. Then you can tell it where in RAM you want to start. But that's all this does. Now, what we want to do is go to 77400 here and investigate. This is the console ROM. And oh, that sucks. How do I send line feed instead of carriage return? Minicom is not a good tool for that, I'm afraid. Control J. 1. That'll work. I'm good with that. Okay. So here's what we're going to do. We're going to go to address 77400. We're going to investigate that. We can see it is, yes, I am using a modern computer. Okay, this is this thing, okay, to look at the micronova. So this is the micronova, the real micronova right there being accessed from a modern computer. And what's cool about this is, again, if we go to, I'm going to just new line here. Actually, I can control L even. It supports that. If I go to 77400, investigate, I can go through here, and we're dumping the console ROM, effectively. There we go. Whoa, that's weird. Oh, because we got to that. That's hilarious. Okay. So yeah, we can just go through this and read all the values of RAM. Theoretically, I could just go console or copy my console history. Bam, there we go. We just dumped the console ROM effectively. But I would like to do this a little more sensibly. Although I'm now wondering how I'm going to handle this. That's a little weird. Let's go back to the manual for the async card. So yeah, 77,400 through that, huh? Okay. Intriguing. Well, that's gonna slightly mess with stuff. Yeah, I'm pretty sure that's the only code or RAM or address location that does that. So that'll be fun. So if we do 77560, yeah. So then 77561 is normal. Okay, so basically we just need to skip 77560. They punch a 16-word hole for the RAM, shadow copy the CPU registers, translate address, display to make that command work. Does that mean we're gonna miss 2 bytes? Yeah, that was the wrong address. 77561. Okay. We're gonna miss data, aren't we, if we do it this way? Or there's nothing good in the ROM there, it's overridden by the RAM. I think it's 16 words. Yeah, so you looked at the ROM and whatever listing you've said you found, so there is nothing truly critical there? Okay, it's hardware, so there's probably like a jump around that or something then. It doesn't really matter. Okay. So we'll read the ranges before and after that, I guess. All right, let's take a look at how we're going to do this. So we can interface with this thing now, which is sweet. The floppy drive is off for the record because we don't want to interface with that right now. We don't, well, it's not that it matters. There's no disks in there. We have flux images of anything I've ever put in there, so it'll be fine. Let's go ahead and grab some code here. I haven't bothered reversing the ROM enough to bother yet. Hay fever is giving me search. Oh, sorry, that sucks. All right, git clone, boom. All right. I have not had an opportunity to actually work on this for real yet, but let's take a look at this. So this is a script that I've been half-heartedly working on because I haven't had access to the, the real interface. But the idea is we're going to be able to access the console in the background here over Python, and I will have commands for reading and writing to RAM. So for example, here we would write the address over serial, then we would write the command read, which in this case is maybe a new line. It might be a carriage return. We'll have to figure out how we handle that. And then we get the data back, and then we have to replace, we get the address first, so we need to nix that, and there's also a space in there, so we replace those with blank, and we strip out, because technically there's a space after the address as well, but then that is our value. ROMs just have all ones of those locations. Awesome, thank you. So that's how we can read an address. But we do have to, actually populate the serial interface here. So let's just quickly go take a peek at my stream integration code, because I already do serial stuff there. And the best reference material is software you already wrote. So we're just going to look at the DecTalk module really quick. AP or output deck talk, import serial, pop that there, and then back to this. Okay, so we define a serial port somewhere, somehow. Here we go. With serial, do serial things. Okay, so serial write. Okay, with serial.serial write bytes, we do kind of want that. 9600, it's probably 8 in 1 already. ASCII, we do want that. We don't want a postfix. We do want our... I don't remember if there's a reason we do that, but we'll probably just keep that. Okay, text. Okay, so we'll do string, data, ASCII, errors ignore. That's all perfect. Reliable code for the deck talk. That deck talk code itself is actually rock solid. Also, I'd like to point out, deck talk has not crashed. There were the audio glitches, but I solved the deck talk crashing this morning. We're gonna pop this. No, we're gonna do this. We need a serial read, which we don't do from the deck talk. We're gonna YOLO this. With why is there like an extra one space right there? Serial read, and then we'll just kind of hope for the best. Okay. All right. So that's probably good. All right, and then this all does that stuff. We did not define a serial port, so let's do port, and then we'll steal this. Oh, actually, I kind of like that more. Let's do that. So, boom, boom, and then back to here, and we'll just yoink that. Boom. Okay. Once you get sufficiently nerdy in reviewing, the algorithm gets pretty good grip on things. Oh, yeah, you're talking about recommendations. I don't know. Okay, let's go to... Actually, first we need to kill Minicom. So, Control A, X, up. All right, close this. Here. All right. So... this doesn't actually run anything. So I think we can do Python 3 dg con import serial unexpected indent. Okay. No, they're all indented by a space? There. If you expected it, then why didn't you just add it? Stupid needy code. Okay. How do I source? You know what? I just import Python 3 from dg con import star .py, the local file. Dude, how do I just import from local file? Python import from local file. Okay, there's no extension. That's what I thought. Hold on, it's actually a hyphen, right? Yeah, hyphen. No. Must have in it to treat like module. Grumble, grumble, grumble. Fine. DG equals, hold on, we need serial wrapper, self.serial port equal 9600. 9600. Wait, no. Speed, actually, you know what, that's all fine, whatever. I guess we can just copy this. There's a smarter way where you call the super constructor so that you pass the value to the original class rather than handling it yourself, or just be lazy. Okay, micronova, we're not gonna do anything. DG dot read address. Let's go with just 1, and then we're gonna print that. Boom. Okay. And then we're going to kill that. And we're going to Python dgcon. Okay. Address, operand, string, and int or something. In 41. Read, replace. For int. Is it being smart and making it a number? Read, or do I need this string? Okay, but that's not. Oh wait, did we set 1 to 1 already? Hold on, let's try this. 400. Okay, that's wrong. Ouch, Ben. Hopefully you don't have the experience I had with monitor terminals being left on too long. And Finn, hello, since your first time chatting, and yeah, that makes sense. Can't have a dash. Python's all picky like. Okay. Why is there a slash? What is it messing up? It's reading 1 character at a time. I gotta have it read like a bunch. Python serial read all. Read line, specify byte count, read 5 bytes. If last the timeout occurs before 5 bytes arrive. So can I just do read 100 and then just, hope for the best? 100. Takes 1 positional argument, but 2 were given.
Imicat subbed as tier 1 and says ISITREDINGONECHROCTERTIME question mark. End of line.
Imicat, thank you for the tier 1 sub and for a number of fingers. I appreciate that. Yep. But that didn't work. Why did that not work? Maybe we could just read line? It's not properly terminated, though. Can we just do that? Hold on, wait a minute. What do we do that? Response, read address, result. You can set what terminates the line. It's a space, technically. But there's more than one space. It doesn't work. We can't set that. That doesn't work. We're gonna do stupid stuff. Equals this. Also, we did not. No, not here. Here. Result. I did not select the whole thing. I double clicked that. Bad Kate. That's it. This. Return. Result. All right. For C in that result plus equal C go. Okay, fair enough. I gotta get rid of that. Wait, what? Read. Oh, I'm an idiot. I put it in the wrong place. Hey! All right, we're getting closer. That's some weird data. The 2000 part's correct, but it's got some other funky stuff going on that I don't understand. $77,400, okay. How about we don't do any replace or strip? Let's just try this. Is that a weird byte string prefix thing that I'm seeing on there? How about instead of string, we make it an int? Return address read int. It'll sort it out or whatever. Yeah, so we'll do string, all that jazz, and then int. And then there. Okay, and then value literal int with base 10. Well, I know I'm getting bytes, but I thought I converted it to string here, but apparently I'm gonna convert. Maybe that'll do it. String has no attribute convert. You know, errors are getting more complicated, yeah. Python, byte, array to string. Convert, I'll take it. We're not doing read line though, because that doesn't work. Bytes has no attribute doohickey. Wait, but I got rid of the convert part. Did I not save it? 21. Decode. 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 That makes more sense. And that is wrong. Also, why is the F string not working? We don't want UTF-8. It's ASCII. What do I have wrong on the F string? Oh, it's single brace. Okay. So it echoes that back. Replace address. Address is an int, but it's a string. You get rid of this. Okay, so there is a space after it now. If I get rid of the, just get rid of all of that again. What is this 00 slash prefix? It does echo back what I'm sending. That's... So I guess that is in the buffer. Okay. So what are the two... Okay. So we should do... Okay. I don't get what the extra zeros are, but maybe I'm getting closer. So it'd be address slash, and then, hold on. Is minicom in this? Yeah, minicom. Okay. So hold on. Enter 77400 slash. Okay, but I screwed it up. So it's just 77400 slash. Address again, 0 prefixed for some reason. And then 00 prefixed on the response. So that Okay. So it's address /0 address space value. Address 0 plus address. Except I removed all the filtering. No, I didn't. Did I not save it? Yeah, I know what I sent. So I sent address / then it's 0 prefixed address plus space. And then whatever is left should be the result. Wait a minute. Yeah. Address read. I don't want, no, we're not printing, we're not doing an octal conversion here. No, not yet at least. Later. This is a horrible way to do it. Strip what you sent. All right, fine. Gosh. I mean, I am stripping what I sent. What do you want? Okay, I read this. I get... Okay, let's break this down. Result dot replace result equal, we wrote address, and then we wrote self command. That's what we sent. Return string result. Error Y. Because I didn't tell it what to replace with. Obviously, it's nothing. It still didn't replace it correctly. Get rid of this line entirely. Okay. So it's at least reading the code. It isn't everything after. Okay, one more time. Let me walk you through this. You type in address 77400. You then press a slash. It prints the address, 0 prefixed, space, then the result. We need to remove what we typed, a 0, what we entered for the address again, a space, and then we get the result, which also has a space after it, so we run strip after. But it's like it's not doing anything. Just straight up replace address with nothing. Why did that work? It's not always the same length if the user doesn't input the correct prefixed address, spacing, whatever thing. So no. Which is part of potentially the issue.
Jason 5 THE4 S2 says CHEER 100 help. I'm still falling. End of line.
Okay. Seriously though, why is it... I don't want to split because I don't know what these zeros are. I don't understand where we're getting that and why it's not just responding normally. 77400 slash... For some reason, we don't receive the 77400 back. We keep the 00 and then the slash and then get all that. Yeah, Ben, that is my problem. I don't know why we're not getting that back. I don't want to delimit it as a solution to an unexpected input. That is a bad idea. So why does it take so long to run? Q might be onto something. Closing the serial port is probably what's doing it. Okay, we can do that. We can handle that. Sure. Now we need to initialize the super class. All right, yeah, that's probably it. I would bet money that is the problem.
Laumo says CHER 100 : At least desktop has not crashed yet. End of line.
Laubo, thank you for the 100 bits. Okay. Address plus command read plus address dot zfill 6 plus space to nothing.
CART 1443 subbed as prime and says end of line. End of line.
Card 1443, thank you for the Prime sub and for 32 months. I appreciate that. Okay. Now we can read values. Thank you, Q. Very good catch. It was closing the port. Ben, we found the answer. Okay. You heard? Thank you, yeah. Okay. Now we can do read range, but that'd be weird. What was the weird one? Hold on, let's just go back here. Minicom 77560. That's the weird one? Yeah. So it's that 77560 until 77600. Okay. End, start, end. Okay, so let's just string this here. Okay, end equals 77577. Save. Thingamajig was never closed. That is there. $40. Result. Replace. What do you mean it was never closed? Int and string. Oh, because it's going to read the whole thing and then print it. Hold on. Let's cancel. Do this. Control L. I'm using that to make sure that the console's in a known state. Okay, our timeout is really long. I'm going to set timeout to 0.1. That'll make this go faster. Okay, I think this will work. Oh, that's beautiful. May stop before the RAM section that might confuse. I just did that. Maybe. I'm pretty sure I did. And boom! There's all... Well, I got wonky there. Why? Huh. Wait, are there multiple? Or did I type in the wrong address? Is it 60 to 600, isn't it? It's, okay. So then 600 to... Okay, that's the full range. There's some weird one slipping through. Oh. All right, how do I do octal? Wait, there's straight up an oct function? Okay. Oh. Pfft, easy. Okay, I genuinely didn't know that was real syntax. What do we think? Is that going to actually convert to a string correctly? Let's find out. It is not. We're going to do math in the Python console, kind of, because I need to know how this works. So 0, 0, 0, 7, 7, 400. Okay. String. Oct. Okay, and then I have to remove the prefix. Ugh, fine. Ah. There we go. Python calculator is forbidden only in this instance, or allowed. And there we go. It's, okay, that's correct. That looked really good. Okay. Bingo. Now, we just have to JSON dump the code. For values Python, JSON dump. Excuse me. I swear I have internet. Import JSON. Boom. And then we just do, yeah, out file. All right. Out file, JSON, ROM, bottom, JSON, doohickey, and then data equal this. Boom. This may not work because this technically returns a list, and JSON dumped, I don't think it'll work with a list. But we could just do Then we do basically the same thing. Top. And then, no, not that. This range. And there we go, probably. All right. Why do we have ROM bottom JSON already? Unhashable typed list. Oh, yeah, I totally screwed that up, actually. That's my fault. ROM. There we go. I know PyList equals JSON array. I swear when I've done this in the past, I didn't like it because it only wants a dictionary. It won't automatically make it a list to begin with. Okay, out file. Yeah, we do that. Okay. And run it one more time. Okay, this is 0 bytes. Gets to 60. It worked, kind of. Did it just like, that stuff's whatever. Okay. We'll rerun this in a moment. Okay, because I think the top one will have got some errant data. Yeah, we need to start somewhere else, somehow. Hold on. Also, minicom, Control L, there, okay. And I really have to end here very soon. Did I just close it like an idiot? 7600, 7560. That's weird. Well, we'll just leave it. Okay. Now there's not going to be garbage in there, I think. Let's just do this. think that'll work. Yeah, that feels like the smarter thing. All right, there. Those are good. Okay. We got the stuff. I don't know why it was weird, but I'll figure that out later. We did just dump the console ROM. All right. That was a success. I am very happy with that. I can shut this off now. But yeah, so we just dumped the console ROM from this. That worked. I have the data. I have to go process it somehow. Right now it's just JSONs, like, it's weird, but that'll be solvable later, so I will do that then. But for now, that is going to be it. So, I am going to go ahead and run the outro here. Boom. All right. Thank you all for being here. We will be continuing this tomorrow because there is more we can do with that code. That was just the start because we still haven't written data back. So we're going to try and mess with that. But yeah, that is going to be it for now. So thank you all so much for watching and hanging out with me and watching me beat my head up against a broken cable for 3 hours. I really thought we were going to make more progress. That was very frustrating. But yeah, oh well. If you enjoyed this stream, you may want to follow to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon or get a shirt like this one. But that'll be it for now, and I will see you all next time.